All right, ladies and gentlemen, let's see if the audio is on. How's our audio? Yes, the audio is on. And let me try to do a few things here. Yeah, it looks like we're good. Looks like we're good. Okay, ladies and gentlemen, let's take a look here as to what is going on. All right, so where are we at? Let me double check. Go to the iPad. Okay. All right, ladies and gentlemen. So remember what we've been working on. We've been working on here with identities. Now I'm going to introduce you guys what we have, what's called the addition and subtraction identities. Okay, so we have some addition and subtraction. So what I'm going to do here is I'm going to bring in some information about this is what it means to do some addition and subtraction, meaning we got sine of angles, s plus t. We got sine of a difference, s minus t. We got cosine of that sum, s plus t, cosine of a difference, s minus t. So these are kind of known as the addition-subtraction formulas. And then we also have tangent, s plus t, s minus t. So what I'm going to do today here is I'm going to try to show you where some of these come from, because we're going to be able to use some more of these identities. We're going to add to our firepower of our identities here. Okay, so you say we have some firepower. Yeah. And let's see if I can do that. All righty. All right, I think we got somewhere. Okay, so let me see. All right. So here we go. So let's say, for example, we want to look at the cosine now of a sum. Okay, so this is cosine of a sum of two angles. So what you guys are looking at is a unit circle here where s and t is the arc length. So it doesn't matter if it's in radians measure or if it's in degree measure. Okay, and you got these points P naught, Q1, Q naught, right? Q naught, Q1, P naught, and P1. All right, so let's see what we can do here with this. So this is on our unit circle. So what that means is that P naught is defined to be at the location, it's the x value is 1 and the y value is 0. So I'm going to share with you guys where this cosine of a sum comes from. So that's what we're looking at for P naught. Now remember our circular function. This is our circular function definition, sine and cosine, right? These are x and y values on that unit circle, right? Cosine is the x value. Sine is the y value. Okay, so what that means here is if I said to you, you know what I can do here? I can even define Q1. Q1, the x value is cosine of t, and the y value is sine of t. So I just want to remind you guys, remember we're coordinating this before with colors. There's the x value, right? Here's the y value. So that's the definition of these points on the unit circle. So you're on that unit circle. Okay, radius is 1 on that circle. And okay, so then you might say, okay, well, what about the location? Let's go now to P1. Let's define what P1 would be. And that's a little bit more sophisticated. All right, so P1, here's what we have. We have cosine now, S plus T, and we have sine S plus T. To have cosine now, the x coordinate, you have sine, which is the y coordinate. Okay? So the last point to define on that unit circle is Q2. And so as we see this, I'm sorry, Q naught, not Q2. Let's say it's Q naught, Q sub 0. There we go. So that last point, Q0, well, that's going to be cosine. Now that's a negative angle minus S, and then sine of minus S. Yeah. Okay. So we got the x coordinate here, and we have the y coordinate here. Okay, so we have all these x coordinates here, and we have the y coordinate. Now, let me say something about these points. Remember, we have some negative angles here. So I'm going to change some of this. What happens if you have cosine of a minus S? Do you guys remember? And sine of minus S. What happens there? Do you guys know what that means? That this is really going to be just what? The same as cosine of S. Let's write down a nice S. And this is minus sine of what? S. Okay. Continue recording. Don't know what's going on with our internet, but okay. All right, now here's what I want you guys to know what's happening here. These are designed in such a way, or I should say something to you. Distance formula. P naught to P1. Okay, the P distance. So by the distance formula, this is how we actually describe it in geometry. Okay, P naught to P1 distance. Okay, and I might do it down here. Let's put it down here. At this distance, by the distance formula here, okay, is the square root of the cosine of S plus T minus, so where's P naught? Oh, it looks like it's 1. Okay, and we're going to take that and we're going to square that. That's by the distance formula. And then you're going to have sine of S plus T minus 0 squared. And that's from geometry, your just your distance formula, right? So the distance from P naught to P1, and now the distance here from Q naught to Q1, there's the distance formula. we take the square root, cosine, now this would be cosine of t minus cosine of s. Yes. We're going to square that. And let me apologize, that's going to be plus right here. Okay? This will be plus here. And we're looking at Q0 and Q1, so that's going to be also now sine t plus sine s. So you have to take that sine t minus a minus makes that plus sine s. We're going to square that. Okay, now those distances are equal. So they're the same here. Now I don't have the ability to highlight this, but what I'm saying to you is that this is P0, P1 is the same as Q0 to Q1. Those distances are exactly the same. Okay? Now, if we move that out of the way here, you might say, okay, does that mean I set them equal? Yes, we set them equal. And what that will mean is you got the two radicals here equal to each other with all this stuff. Now that implies if I have two radicals that are the same here, okay, whatever I have under here, let's call that A, whatever that is. Okay, and let's call that B. What that means is that A equals B. They're the same. And so we see cosine s plus t minus 1 squared plus sine s plus t. That's going to be squared. That's the first part right up in here. Okay, this is under that first radical. This is like what we're saying is A. And maybe we'll use different colors. We'll use gray. And this is gold. That's going to be equal to cosine t minus cosine squared plus that sine t plus sine s squared. Those are the same. Yes?
Is that a C or parentheses?
Which one are you looking at?
The cosine. So you know where the radical A and B, the one under it?
Yeah, no, that's a parentheses here. Because let's go back here. If you guys remember from geometry, you remember the distance formula from geometry? Right? This is the distance formula from geometry here. So this is in parentheses because we're going to have to do some algebra now. So the algebra we have to do is right up in here. So what you have here, and it looks like, I guess there's an internet issue, so we're recording but not broadcasting, whatever this internet problem is. So for those people at home, you never know. That's why you guys want to try to make the effort to be here. It's only if, I guess they can't hear me anyway. It's only if you have that emergency situation, right? Really, if you're sick or something. All right. So now we're going to have to use some algebra. So you say, what is this algebra that we have to do? Right? Remember what if we have something like this, a plus b squared, what's that going to be? Isn't that a squared plus what? 2ab plus b squared. You have a minus b squared is going to be what? A squared minus 2ab plus b squared. There's your algebra. So we're going to do the gray portion, okay? So we're going to use our FOIL. This is, remember, this was FOIL here from algebra. Right? FOIL. So let's see what we get by FOIL for each. All right, well, that's going to be in gray. We got cosine squared s plus t, right? Minus 2 cosine s plus t, right? Plus 1 squared plus sine squared s plus t. This is the gray that we have. And then the gold that we have, let's put that in gold. Cosine squared t minus 2 cosine s cosine t plus cosine squared s. Now this is, I did the first one, so we're going to have to use a couple of rows here. Right? Looks like, yeah, it looks like we're good. And then here with the s now. So now we're going to say this will be plus sine squared t plus 2 sine s sine t plus sine squared s. That's just by using FOIL on top here for the gray and the gold. They're equal to each other. Just using your algebra formulas there. Now, here's the thing about this, okay? If you guys remember Pythagorean identity here, I guess we use pink. What is this plus this? Isn't that 1? Is that right? By the Pythagorean identity, that's a 1. So then we have 1 minus 2 cosine s plus t plus 1 will equal, now we're going to use another Pythagorean identity here. We got cosine squared t, let's go back. Cosine squared t plus sine squared t is another 1, and that's minus 2 cosine s cosine t plus, by the Pythagorean identity, cosine squared s plus sine squared s is another 1. So that's plus another 1 plus, that's going to be the 2 here. 2 sine s sine t. So we get 2 minus 2 cosine s plus t equals 1 and 1. This is another 2 minus 2 cosine s cosine t plus 2 sine s sine t. Okay, so we're gonna make this color here. Where is that? Yeah, let's color coordinate this. So this is that gray still. That's what it simplifies to. And then here's the gold. Factor out the 2. 1 minus, and I think, did we make a mistake? No, I think we're okay. Yeah, we're good. Okay. Well, we don't have to factor the 2 out. Here's what we're going to do here, right? So this is where we're at. Notice if I subtract 2 from both sides, doesn't this 2 go away? Right? So now you have the following. Negative 2 cosine s plus t equals negative 2 cosine s cosine t plus 2 sine s sine t. All right, now we could do a couple of things. We could divide both sides by a negative 2. And if we do that, let's do that. Let's divide both sides by a -2. Okay. We still have the first equation in gray divided by the next equation in gold. Okay, so you guys know, divide both sides by 2. Let's see what we end up getting here. We end up getting what? Okay. Now, all right, let's take a look here. So this is an identity here. And this, ladies and gentlemen, if I can get what I need. Oh, here we go. Over here. Let's double check. Is that where they have here for the cosine of the sum, s plus t? Isn't that cosine s cosine t minus sine s sine t? Right in the middle there? What do you guys think? Is that okay? So what I want to remark here, this is a sum formula. This means to add. This is a sum. Mm-hmm. Okay, now the proof's in your book, just so you guys know. You guys can take a look at that. Now, you might say, where does the difference formula come from? It comes from this formula. Where does the difference formula come from? Right? So, what is the difference? Now I'm going to do this, ladies and gentlemen. Tell me if you guys agree with this. Okay? Cosine s minus t. There's a difference here. Do you guys know how you can write a difference? A difference is written as a sum of a negative. All right, you guys okay with that one? Does that make some sense here? Subtraction is addition of negative. Okay. Now, here's the thing. Here's the thing about this. Okay. Now, now I can use the sum formula over here. There's a sum formula here, right? There's addition. So now there's addition here. You got this addition. So you say, can I use it? Yeah, you can. That means you got cosine of s, cosine minus t, minus sine of s, sine minus t. So that cosine of a difference, we start to use the even and odd functions again. You say, what do you mean? Where do you use the even and odd functions? Right in here. What's cosine minus t? Isn't that just cosine t? This stays the same. Okay. And then you say, well, what is this? This is sine s. And then this will be sine of t, but it's going to be plus now because you're going to use the even and odd functions, right? Remember this? What is cosine? I think cosine is even, and sine is what? Odd. So, ladies and gentlemen, what you end up getting now is very simply this. I'm going to put this over here. Okay, so we got that even and odd property. Let me bring this up here. Let's give you the difference. So this is now a difference here. Cosine of a difference, cosine S, cosine T, and then that's going to be what? Plus sine S, sine T. There you guys go. So, all right. Now, what I'm going to do here with this, ladies and gentlemen, is I'm not going to prove the sine S plus T. We're going to write it down. I don't even think your book does that, but okay. Sine S cosine T. Now that you guys see where some of these things come from, we're going to write them down here. Cosine S, right? And that's sine T. So this is a sum formula, right, for sine. And I'm just copying this one now for you guys. Now that you guys see that these things just don't fall out of the sky, they're proven. And then similarly, how they get the difference is doing the same thing I just did. I'm going to move this out of the way. So how you get the difference is done the same way, right? All right, so this is going to be your difference formula here. Okay, you guys okay with that? They just didn't fall out of the sky. They were proven. You did the same even and odd stuff here. Once you have the addition formula, you can actually just apply the even and odds. All right. And then you might say, where does tangent come from, right? Well, tangent, you guys look at these tangent of a sum. I'll derive some of that for you guys here. So what is tangent, right? Well, you're going to start with tangent of a sum. We're going to write as sine over what? Cosine. Okay, sine over cosine. Now, and again, these are all in your book. So you guys say, oh, are these in my book? Yeah, they're in your book, 7.2. So you might say, what is a sine? Where does the tangent of that sum come from? Right? Remember, we've been working with some of these identities. We have some proof skills. Proof skills are important. So now with tangent of the sum, here's what you guys want to do. Focus on this right-hand side. I'll just put it in pink, I guess. Okay? We're going to put that numerator here. All right, so think of it this way. You got that numerator, and we have a denominator here. I'm going to prove this stuff. So in gray, you just use the sum formula for sine. You say, which sum formula? This one right here. In gray. So that is going to be sine s cosine t, right, plus cosine s sine t. And that's going to be over cosine s cosine t minus sine s sine t. Okay, you guys okay with that? Now, here's what I'm going to do here. You might say, well, how do they get what they have here for tangent of the sum? Right in here you go. They got tangent of a sum. How did they get this? Well, here's what they did. Let's see if you guys understand what I'm going to do here. I'm going to try to see if I can do this here. I'm going to move it out of the way. Okay, I'm going to say to you guys, don't I if I have a fraction times 1, you want to scroll it up?
For the denominator,
Yeah.
cosine minus, isn't that supposed to be plus?
Well, is it cosine? Do we make a mistake? I might have made a mistake. Cosine s plus c is supposed to be plus. You're right. Okay. So here's what I'm going to say. Times 1, isn't that, let me double check for the tangent. Yeah. Is it? Let me see. Sine over cosine. This is the sum, right? So sine st cosine st. Cosine s. No, that's minus. It is minus. Sorry. It is minus. I'm okay. All right. Now, if I multiply this by 1, don't we preserve the fraction? Right? And then any triangle divided by itself, isn't that also 1? Now you say, well, what's your point? You know what I'm going to do is this. I don't know if I can fit it there. I'm going to divide 1. Okay, I'm going to use it. I'm going to write it down right here. It's this thing, 1 over cosine s cosine t. This whole thing. And maybe I'll put that in a triangle here. Right? So I'm going to say triangle over triangle. Isn't that 1? Anything divided by itself is 1. So what I'm really going to say is that you're dividing every term by cosine s cosine t. Okay? So I'm going to move this down. I'm going to try to write it this way. Cosine s cosine t. Cosine s cosine t. This is equal. All right, so you say, if I divide every term by that, this is what this looks like now. Okay, without having to write everything all over again. I'm dividing now every term by that because of the algebra. Okay, so that's kind of where this is going. If you guys know now, where else this is going is right in here. Let me see if I can get another color. I don't know, maybe pink. You guys know, what is sine S, cosine S? Pink, and then maybe purple. Right? What happens with this? Do you guys know? Isn't that, what's sine over cosine? Isn't that tangent? Good, tangent S. What's cosine over cosine? Isn't that 1? Now I'll do the same thing over here. Okay. Cosine over cosine is 1. And now over here I got sine over cosine, and that's just simply tangent. So it's tangent of what? T. Over, well, what's going on here? Isn't this also 1? And this is also 1? This is what we're saying. So this is 1 minus. Sine over cosine is tangent S, and then sine over cosine again. So maybe we'll just do it like this. 1, 1. And over here, you have the colors that are pink and purple. So you got sine over what? Cosine. Tangent of a what? Sum. And there it is. Okay. So you might say, is this where they get the tangent of a what? Oops. Tangent of the sum formula right here? Right? Isn't it tangent S plus tangent T divided by 1 minus tangent S tangent T? This is where they get it from, ladies and gentlemen. This is a proof of that. Same formula. Now, this is a sum formula. Where are you going to get the difference formula? Here. We can write again tangent of the sum. Oh, no, let's write it this way. Tangent of a difference can be described as tangent of S plus that minus T. Okay, same thing as we did before, using the sum formula. So you could say, isn't that tangent S, okay, plus tangent minus T. We're using the sum formula here. 1 minus tangent S, tangent minus T. So then that difference, remember, what do you guys know about this tangent here? Or is tangent even or odd? They're odd functions. Is that right? So that means this is going to be now, instead of a sum, we could pull out the negative sign. Remember what it means to be odd? You pull out the negative sign. So that's going to be minus tangent T over 1, now plus, because you pull out the negative sign, and minus and minus is plus, tangent T. So what do you get? Tangent of that difference here. Anyway, now erase that here. Let's double check. Tangent of the what? Sum. Now tangent of the difference. So we're going to double check here. see if those formulas were correct. Tangent of a difference. Tangent S minus tangent T is 1 plus tangent S plus tangent T. So, ladies and gentlemen, here's what I want to remind you guys here, just to say this to you. I wanted to prove to you guys where some of these formulas came from, where most of them came from. I didn't do sine of a sum, but, you know, your book even says, okay, you can maybe, you know, figure that out, sine of a sum. But at least I'm giving you guys the formulas. Now, remember, when you use them, I give this to you guys on a formula sheet. So you guys are going to use them, but I'm going to give it to you on a formula sheet. Okay? You guys understand what I'm saying? So you say, well, how do I use these formulas? I proved them to you essentially using geometry and algebra. And so, for example, they might say, determine the exact value without your calculator. Right? So you say, well, how do I use these things? What did they say? What is sine of? Without a calculator. Oops. Come on. Sine of maybe. I'm going to think about this. 75 degrees. This is kind of a standard question. And this is, again, without what? Without a calculator. So you don't use a calculator for this. So how would you do that if you want to determine the exact value? So focus right in here on the angle here. Okay? How do you write 75 degrees? How can you write that? Can't you write it as 30 degrees plus what? 45? So this problem becomes sine of 30 degrees plus what? 45 degrees. So you're going to replace that with what you have here. Okay, does that sound okay? All right, now you say, well, what do you use now here? Well, use your formula. And sometimes I just have this as, I write it as AB. I think if I go back over here and you say to me, all right, let's take a look at this stuff online. Oh, what happened? That's weird. Oh. Okay. 241. All right, let's look at the cheat sheet. Well, they did alpha and beta. You guys see it over here on the right side? They do alpha and beta. They didn't do S and T. It's alpha, beta. Sometimes they write A and B. Like for a calculus class, you know, I write A and B. Okay. Whatever. So what is sine of a sum? Do you guys remember sine of a sum? You could look at the formula sheet. You go, oh, sine of sum is sine A cosine B plus cosine A sine B. So it's sine cosine plus cosine sine. Sine 30 degrees. So maybe you want to see that way. Sine A cosine B plus cosine A sine B. So that's going to give you sine 30 degrees cosine 40. plus cosine 30 sine 45. Okay. Oops. It's kind of getting tight there. All right. How about this? Yeah. So how about this? Let's do it this way. 30, 30 plus 45, 45, 30, 45. Okay. So I'm just going to say to you guys, refer to the formula sheet at this point. And here's kind of what's expected, right? Didn't we start all this by exact values? Do you guys remember? We started everything with exact values. So what's expected is that you know what sine 30 and sine 45 degrees. So go back to geometry. What happened in geometry? What, don't you have to only know two triangles? Okay, remember this. This is what I'm going to remind you guys. There's only two special what? Triangles to know. This one and what? This one. Okay. So you might say, where does this one come from? This is 60. This is 60. This is 60. Don't we do what? Bisect this. This was 2. This is 1. This is 1. This is 2. And I think this is square root of 3. Is that true? So once you bisect, though, this is going to be 30 degrees. Now remember, this is 45 degrees. So what is this? 1, 1, and this is what? Square root of 2. So, ladies and gentlemen, this is kind of the deal, right? You just have to remember, this goes back to the exact values here. This goes back to the two special triangles you need to know, like you know your name. What else you guys have to know? Do you guys remember? After you have this, what else you guys have to know? I would say something like this. I think you have to know the ratios. Is that true? So what is sine? Can you guys tell me what is sine here of 30 degrees? Right? You need to know what sine of 30 degrees is. What's sine 30? What's the definition? Opposite over what? Hypotenuse. Is that true? What's cosine 30 degrees? Isn't that going to be adjacent over hypotenuse? Is that true? So you're getting here, this is what you guys really need to know. You really need to know the basics. If you're strong in the basics, you can do anything. What's sine of 40 degrees? What's the definition of sine again? Do you guys remember? Opposite over what? Hypotenuse. Okay. What's cosine of 45 degrees? You guys remember that one is? That's also what? Opposite over what? Hypotenuse. Sine 75. What's this going to be, ladies and gentlemen? I just replaced sine 30 with what number? You guys know what this is? 1/2. What's cosine 45 degrees? Square root of 2 over 2. This is what I replace that with. What's cosine 30 degrees? Square root of 3 over 2. What is sine 45? Square root of 2 over what? 2. So what do you guys end up with if you do the arithmetic now? What's the arithmetic going to give us? Isn't it 1? It's going to be what? The square root of 2 over 4 now. Is that right? Plus what? Square root of 3 over 2 times square root of 2 over 2. Isn't that plus the square root of 6 over 4, ladies and gentlemen? And some books will have you guys factor out the 4. So, ladies and gentlemen, there you go. Final answer. Square root of 2 plus square root of 6, everything over what? 4. Now, that's what you got using the sum formula here. Okay? This is what they want you to do. It's square root of 2 over 2. Right? Because it's 1 over the square root of 2, but you rationalize the denominator, right? Square root of 2 over 2. So this goes back to like the first week. So let me move this here if I can. Oh, is this a pencil? What's the deal? Okay, now compare and contrast to this question here. This is sine of 75 degrees. You might say, okay, what if they gave me this here? Cosine of 15 degrees. Another example here. And I can't use a calculator. No calculator, ladies and gentlemen. Ooh, that's the idea here. Now, remember, how do you write 15 degrees again, right? You guys remember? How do you write that? Anybody know? Let's see, let's get the red. Can we say 45 degrees minus 30 degrees? Is that right? So this is cosine now. 45 degrees. I'm sorry, let me be careful here with this. Isn't that minus 30 degrees? So we have to write this as a what? This is a what? Difference. Because 45 minus 30 is what? 15. Yeah. Yes, exactly. That's a very good question. Here's the point. Remember, these problems are all specially chosen. They're all specially chosen. You say, why are they specially chosen? Because they're going to give you questions where you use angles. Let's write that down. Use angles you know. And you say, what do you mean you know? You can deduce. You can deduce without a what? Calculator. That's the whole point. Not to use a calculator. right? You go, well, Mr. Judge, my life's easier to just use a calculator. Okay, well, good for you. But what if one day you're asked to write that program to do the same thing? What? What? I might be asked to do that? Yes. Using a special language like Python or something else. Because you guys live in what kind of age? Technology age. Is it the last days? Oh, it's the last days. You guys live in the technology days. This is your era. This is what you guys should be salivating at this because you guys grew up on technology. You guys know what I mean? That's how it works. So you go, well, how would I do this? Use your identity sheet. Cosine, what's the cosine of a difference? So believe it or not, this is programmed, you got cosine of a difference. So, all right. What's cosine of a difference? Isn't it cosine of the first thing, which is 45, times cosine of the second thing, which is what? 30. Is that true? So cosine of a difference. So this is going to be plus what? Sine of 45, sine of 30. There you guys go. Now, do you guys know what cosine 45 is? Say yes. How do you guys know what cosine 45 is? It's right over here. Is that right? I know it's a different color, though. Square root of 2 over 2. What's cosine of 30? I know it's a different color. Cosine of 30 is what? Square root of 3 over 2. Is that right? You already have that. Square root of 3 over 2. What's sine of 45? You have that one too. Sine of 45 is what? Square root of 2 over 2. So you guys want to use those things. And what's sine of 30 degrees, ladies and gentlemen? Sine of 30 is what? 1/2. And then there was plus. So now you just use your algebra here and you say, okay, square root of 6 over 4 plus square root of 2 over 4. And, sometimes they just factor out the 4. And ladies and gentlemen, there you go. This is the exact value. But the intent is for you guys to use the identity and what else? Use angles that you know. It's not designed for you to jump and use a calculator. They're designed for you, these identities are designed for you to use them because it's going to come up. Now, remember, you might say, well, it comes up. Yeah, it comes up with later math and science topics that you use to simplify. That's how it comes up. Cosine 15. Tangent. Tangent of 195 degrees. You might say, I mean, you might be able to do that. I don't know. What can I do there? Yeah. 195. How about this? Hmm? I mean, 230. There's a lot that you can use, but you want to use angles that are going to make your life easier, not harder, right? So there's a lot really you can use. What should you guys do with that? What do you guys think? There's a lot you can use. It's not just one. You can use a sum. You can use a difference. Can I say 150 plus 45? What do you guys think? Is that 195? Okay. So you don't have to use this. You're just going to have to deduce this without a calculator. Okay, so there might be other angles you can use. So I'm going to use here, ladies and gentlemen, this is a sum. Is that true? Okay. Now, I want you guys to note, what is tangent of a sum? It might be good for you to write some of that down. And I know, like I said, every book might have different letters. I like A and B. So I have tangent of a sum would be tangent A plus tangent B, everything over what? 1 minus tangent A, tangent B. Okay? So if we use the sum formula, what do we know this is going to equal? We have to find tangent of 150 plus tangent of what? 45 divided by 1 minus tangent of 150 degrees, tangent of what? 45. Is that true? Double check. Maybe I need colors. So does anybody happen to know what is tangent of 45? Maybe you know that already, and it's good if you know. Without a calculator, ladies and gentlemen, how do you know this without a calculator? What's tangent 45? Go back to a special triangle. What's the definition? You got to know your ratios. Opposite over adjacent? What happened here? Isn't that just 1? So this is just what? 1. This is what? 1. What does this equal then? Tangent of what? 150 plus 1 over 1 minus tangent of what? 150. So what do you guys think we have to deduce here? 150? So we need to know what is tangent of 150 degrees. Again, without a what? Without a calculator, just using your identities. This is why you study identities. Okay. So anybody remember that homework you did on this? You did some homework on this. Anybody know what I'm talking about? What do we do on this here? How do you deduce tangent of 150? I'm going to have to get out another picture. Let's find it. What is it? I think it's going to be, where is this? Where is it going to be? Oh, there we go. See if we can make this bigger. So you remember this tangent of 150? You got 0 degrees. What do? You move that all the way to what? 150 degrees. Anybody do that homework yet? I hope. How do you do this? You guys remember? All students take what? Calculus. What is your reference angle, ladies and gentlemen? Because I'm going to get out my purple. I remember. I need a reference angle. Is that right? Isn't the reference angle right here? You say, or right here, whatever you want to call it. What angle's there for the reference? Huh? What is it? 30 degrees. Good. Outstanding. You guys did the homework on that. Outstanding. 30-degree reference angle. So what I need to know is what is tangent of the reference angle of 30 degrees. Without that, I can't do this question. So I have to go back now to what? The special triangle. So you go, oh, okay. Special triangle. Yeah, where's the special triangle tangent 30 degrees? 30 degrees? Do we still have it? We sure do. You just need to know the definition. I'll put it here. What's tangent of 30 degrees? Anybody remember? Opposite over what? What is it? What's that ratio? Tangent 30. Opposite over? Which is what? 1 over the square root of 3. Rationalize that. Isn't that just the square root of 3? Square root of 3 over 1. Is that right? Which is the square root of 3. Over 3. Sorry. I got to drink my coffee. Square root of 3 over 3. Is that true? If we rationalize that? Okay. Square root of 3 over 3. So, ladies and gentlemen, that's the reference. Now that we have the reference, we can answer the question of tangent of 150 now. Now we can answer. Is that right? What's tangent of 150? Negative. That's right. Why negative? Because all students take what? Calculus. This S means that tangent is negative. Sine is positive. It's the only one. Cosine's negative. So that's why this is a what? Negative square root of 3 over 3. Okay? Tangent of 30 is square root of 3 over 3. Tangent of 150 is negative. So you say, what do I do with that? Well, we replace this with what? Negative square root of 3 over 3. Replace this with what? Negative square root of 3 over 3. Okay, now we're going to write this down because there's going to be some algebra here. So you say, what do you mean the algebra? Well, minus square root of 3 over 3 plus 1 over what? 1 minus a what? Minus. 1 minus the minus. Isn't that going to make that plus? I think that makes that plus, ladies and gentlemen. Yeah. Anyway. So if you look at some books, the algebra looks like this. They're going to rearrange the numerator. And now this is a complex fraction here, okay? Right? So we're going to have to do, this is a complex fraction. You're going to have to do some arithmetic in the numerator and the denominator. So what do I need to do? Do you guys know? Well, yeah, you can write the 1 as what? You can do that, in all honesty. You could multiply 3 by top and bottom. But sometimes people want to see every detail, right? They go, Mr. Judge, can you give me the details? All right, devil's in the details. Complex fraction. What do you guys think? Do you guys know what happens here? You guys know? You could get rid of the 3's. Why? Why can we get rid of those? Because we're going to write it as a quotient. And a quotient is written how? Multiplied by the reciprocal. Okay, so that goes away. So you get 3 minus the square root of 3 over 3 plus the square root of 3. Okay. Now you might say, boy, Mr. Judge, I looked in back of the book, and I was always taught that you have to rationalize a denominator. Do you guys remember what I'm talking about here? Do you guys remember the algebra there? What algebra did you guys use here? Because if you look in back of the book, you guys remember? You gotta, how do we rationalize that? You have the conjugate, is that right? The conjugate of this 3 here. So we're using conjugate. And you might say, what is that? Well, that's 3 minus the square root of 3, 3 minus the square root of 3, and what happens? Well, it's kind of conjugate. It's really conjugate-ish. Conjugate-ish. That's going to be 9 minus 3, and then on top I have to use FOIL here. So you might see 9, well, let's do this here. Outer, inner, you could use an algebra formula. That's going to be minus 6 square root of 3 plus 3. Okay? So you might say, what did I use for the algebra? Well, remember this, a minus b squared is a squared minus 2ab plus b squared. Let's see if I did my algebra okay. I think I did. Yep. So you'll often see this as 12 minus 6 square root of 3 over 6, or just simply 2 minus square root of 3. So, you know, you're looking back at the book, and ladies and gentlemen, this is what they have you do. Okay, this goes back to using algebra from like pre-calculus, or it's actually really intermediate algebra. You're using conjugates. You guys remember intermediate algebra? Remember that kind of thing? So in some calculators, not every calculator, this is what's called the symbolic answer. And it'll give you 2 minus the square root of 3. And this is just using this, you know, technique here. Okay, so let me ask you a question, though, just so you guys know. You guys want to see that there? Let's ask you guys this question. Recall something here. Let's have you guys recall. What if they gave you radians instead, right? What if they said, what is sine pi over 12? Do you guys know? What would you do with this? What might be a good thing you can do? You know what I might want to do? I might want to convert. You have this here. What is pi over 12 in terms of degrees? Maybe you want to convert. Do you guys know what pi over 12 is as a degree angle? Huh? What's pi over 12? Is that 180 divided by 12? What's that 180 divided by 12? Am I awake yet? Can I divide 180 with 12? Oh, man. Anyway. I don't know. Let's have you guys think about that. What would you do with this one here? Because we're out of time. It's in your book, but we're out of time. So, ladies and gentlemen, this is 7.2. And we just started that. So what I'm going to do here is this. 7.2. See if it's there. Yeah. It's already in Canvas here. So we just started some of these here. So I want to make sure, is the internet working again? Is it going down? What happened here with the internet? Hey, internet, where are you? Anyway, you guys can't see that. Let's get back on the internet if possible. And let's see what happened here. Guess it's going to make me log in. So let's do this. Yeah, let's see. It might work now. Okay. Yeah, there we go. So here we go. So what you guys can see, we're getting started on 7.2, 1 to 12 all. You guys want to try some of those, okay? And there you go. So hopefully, again, I'll try to upload this later for you guys, but it looks like we have a weird connection today.